Is Earth the only place in the universe where life exists, or are we just the tip of an interstellar iceberg? These questions have intrigued humans for centuries, sparking countless debates, theories, and even sci-fi movies. As we delve deeper into the cosmos, our understanding of the universe continues to expand, almost as rapidly as the universe itself. Just think about it. The universe is vast, beyond our comprehension. It's filled with billions of galaxies, each housing billions of stars. Around these stars orbit countless planets. Among these we found a special category, a category that triggers our curiosity: Earth-like planets. These celestial bodies resemble our home in many ways, from their size and composition to their potential for water. But does resemblance guarantee life? That's the million-dollar question. Science doesn't have a definitive answer yet, but the possibility is tantalizing. As we gaze upon the stars, we can't help but wonder, are we alone? Scientists have been tirelessly searching for planets that resemble our home, Earth. To understand this search, we need to delve into the methods that scientists employ to find these Earth-like planets tucked away in the vast expanse of our universe. One such method is the transit method. Picture this: you're sitting in a park, watching birds fly across the sky. Suddenly one of them passes directly in front of the sun. The bird momentarily blocks out a tiny fraction of the sun's light, causing a slight dip in its brightness. This is exactly what happens when a planet transits or crosses in front of its star. By observing these minute dips in starlight, scientists can deduce the presence of a planet. Then there's the radial velocity method. This method takes advantage of the fact that a star doesn't just remain stationary while its planets orbit around it. Instead, the star and its planets orbit a common center of mass. This causes the star to wobble slightly, and this wobble can be detected from Earth. The size and speed of this wobble can tell us a lot about the planet causing it, including its size and distance from the star. Now, let's talk about the Kepler and TESS missions. Kepler, launched in 2009, has been an absolute game-changer. It has discovered over 2,000 confirmed exoplanets, with another 2,000 potential candidates still awaiting confirmation. Then there's TESS, the Transiting Exoplanet Survey Satellite, launched in 2018. TESS scans the skies for transiting exoplanets in our cosmic neighborhood, and it has already found over 2,000 potential exoplanets. These missions, along with the ingenious methods used by scientists, have opened up a whole new world of possibilities. We're not just looking for any planets anymore, we're looking for planets that could potentially support life as we know it. Planets that could have liquid water, a suitable atmosphere, and just the right conditions for life to thrive. The hunt for Earth 2.0 is far from over, but we've already found some promising candidates. Let's take a journey through space and time to meet some of the most Earth-like planets discovered so far. First stop, Proxima Centauri b. This intriguing exoplanet orbits the star Proxima Centauri, which is the closest star to our Sun, a mere 4.2 light-years away. It's roughly the same size as Earth, giving it a familiar feel. But what makes it particularly interesting is its location within the habitable zone of its star, also known as the Goldilocks zone. That's the distance from a star where a planet could have liquid water on its surface, not too hot, not too cold, but just right. It's a key factor when it comes to the possibility of life as we know it. Next on our cosmic tour is Kepler 186f. This exoplanet resides in the constellation Cygnus, nearly 500 light-years from Earth. Kepler 186f is special because it's the first planet discovered within the habitable zone of a star that is roughly the same size as Earth. It orbits a red dwarf star, which is cooler and less bright than our Sun. This means that if you were to stand on the surface of Kepler 186f, the sunlight would appear dim and red-tinted. Yet despite the dim light, the conditions could still be right for water and possibly life. Finally, let's travel about 40 light-years away to the constellation Aquarius, where we find TRAPPIST-1e. This is one of 7 Earth-sized planets orbiting the ultra-cool dwarf star TRAPPIST-1. This planet is roughly the same size as Earth, and also resides in its star's habitable zone. What's more, its density suggests that it could have a large iron core, which would make its composition similar to ours. This, along with its potential for water, makes TRAPPIST-1e a particularly exciting candidate for habitability. Each of these exoplanets is unique with their own set of characteristics and conditions, yet they all share one thing in common: the potential for water and possibly life. These distant worlds may not be identical twins of our home, but they do have similar traits. They offer a tantalizing glimpse of what Earth-like planets could look like. They remind us that our world is part of a larger cosmic family, A family that we're just beginning to get to know. Just imagine, out there in the vast cosmos, there may be other Earths waiting to be discovered. Other worlds where the conditions are just right for life to thrive. As we continue to explore the universe, who knows what we'll find? These distant worlds, while not identical, offer a tantalizing glimpse of what Earth-like planets could look like. The discovery of these Earth-like planets opens up a world of possibilities, quite literally. When we gaze into the cosmos, we're not just starstruck by the sheer beauty of it all, we're also intrigued by the potential of what could be out there. Imagine for a moment a planet just like ours, teeming with life but distinct in its own unique ways, a place where we could set foot, breathe the air and call it a new home. That's the potential of these Earth-like planets. There's an entire universe to explore, and these planets could be the stepping stones to our cosmic journey. Of course, the journey to these distant worlds is not without its challenges. They're light years away, meaning even if we traveled at the speed of light, it would take us years to reach them. Then there's the matter of surviving the journey and adapting to the conditions on a completely new world. But, as we've seen throughout history, human beings are incredibly resilient and innovative. The potential benefits of colonizing these planets are enormous. They could be rich in resources we've exhausted here on Earth, offering a new lease on life for our species and our planet. And let's not forget the scientific discovery. The chance to study these worlds up close, to understand their geology, their climate, their potential for life, could revolutionize our understanding of the universe and our place in it. And what if we're not alone? The search for extraterrestrial life has always been a driving force in space exploration. The discovery of life, even microscopic on another planet, would be one of the most significant events in human history, altering our perception of life and our place in the universe. The potential of these Earth-like planets is limited only by our imagination and our determination to explore. So, let's continue to reach for the stars, to push the boundaries of what's possible, because who knows what wonders await us out there. As we stand on the brink of a new era in space exploration, what does the future hold? The next few decades promise to be an exciting time, with new missions already being planned and cutting-edge technologies being developed. These advancements are set to propel us further into the cosmos, deepening our understanding of Earth-like planets. NASA's upcoming mission, the Habitable Exoplanet Observatory, or HABEX for short, is one such mission. Scheduled for the mid-2030s, HABEX aims to directly image planetary systems around Sun-like stars. This mission could potentially find Earth 2.0, an Earth-like exoplanet within the habitable zone of its star, where conditions may be ripe for life as we know it. In addition to HABEX, the European Space Agency is planning the Plato mission. Set for launch in the late 2020s, Plato will focus on finding and studying a large number of Earth-sized planets, further expanding our knowledge of potential life-supporting worlds. But it's not just about these high-profile missions. There are also advancements in technology that could revolutionize how we explore space. For instance, the development of propulsion technologies like ion drives and laser sails could drastically reduce travel times, making distant exoplanets more accessible. Furthermore, advancements in AI and machine learning could help us analyze the vast amounts of data collected by these missions more efficiently. This could speed up the process of finding potential Earth-like planets and even improve our ability to detect signs of life. The future of space exploration is full of possibility. With each new mission, each new discovery, we inch closer to answering one of humanity's most profound questions. As we continue to explore the cosmos, we may soon find the answers to some of our most profound questions. Are we alone, or is there a second Earth waiting for us out there?